I know there will be a lot of questions. It's really hard to do a workshop in 45 minutes or 1 hour, because usually what you have to do for a workshop is like have a full day workshop where you go with people through all the things on their own computers, they build the stuff and so on, So I just want to give you a quick introduction into building Starling games and what it actually means. If you want to take a photo of this slide, this is basically summarizing the currently available 2D frameworks for Stage3D. There are even more of them. For instance, I'd like to add one more. It's called GPU Sprite. GPU Sprite is basically a single, it's a single class provided from Adobe for developers who are willing to start building their own 2D frameworks on top of it. It's very fast, but it's very stupid because it doesn't do all the nice stuff that, for instance, Starling, ND2D, Genome 2D, and Excel do. So if you need a simple framework that is really tiny little, then definitely check out GPU Sprite. If you know Flixel for bitmap blitted games, then Excel is basically almost the same, but rendering on Stage3D. Genome 2D is using component-based model for rendering and for structuring your assets inside the game. It's very similar to Unity, for instance, so you attach different properties and functionalities onto components, and this is how Genome 2D works. Starling is basically the inheritance model, from this playlist. So people often ask me, like, which one should I pick, and it's hard to say. Some of them are fast. Genome 2D is very fast for rendering. But for instance, in terms of learning and documentation and easiness of getting into one of those frameworks, Starling is the best, because there is a book, there are video tutorials, you can start with it very easily. You basically know everything from display list programming from the previous Flash, because Starling is just the same API, it works the same way. So let's have a look at how this actually works if you want to build something by yourself. So I just quickly ran Flash Builder here, and I'll show you how this works. So what you basically do if you want to start building Starling framework games, go to starlingframework.org website. It's a free open source project built by guys from Austria, very close to Salzburg. And what you basically do here is just click download, and you can go to the repository on GitHub and just get a code from the repository. You don't even need a code, you just need a Swig library, and that's basically it. There are a lot of samples you can just run. You can investigate how the samples works, and so on. The purpose of this workshop is to tell you the differences between display list rendering and Starling rendering, so you basically understand how these things work under the hood, and I just want to simplify you the getting started guidelines for Starling. So, how does it work? So let's start a quick project here. Are you guys coders? Cool. That's my group. Yeah. So, new ActionScript project. Just say, hello Starling. Choose the web. Now we just add a Swig library for Starling. I have it here in VSS primary feather. Starling framework for April 24. Starling.swig. OK. And finish. So now I edit Starling library. So what I do here is, for instance, imagine that we are building a game for iPad. So of course we want frame rate 60 frames per second. We want height 768, and width it's going to be 1024, and background color is going to be like I don't know, black. Black. Okay. So we've got black color. We've got everything set. So what we do here is we just set up a single instance of Starling. So we just create variable mStarling, new Starling, And one of the first things you have to pass here is a root class. Okay, I'll just maybe make the font a bit bigger so you can actually see that. Okay. So you basically pass one of the classes. We will create it later on. And then just pass stage. Simple as that. Now we create the private instance variable, and we basically say mStarling start. So now we have Starling running. Then we have to just add one Sprite class that will do all the rendering for the whole project. So we just say new ActionScript class game, and it's gonna extend Sprite. But this sprite is going to be from Starling.display, not from Flash.display. So we just pick this superclass, hit finish, boom. We have Starling class. And here we do all the rendering. Catching up so far? It's easy, isn't it? So what we do here, one simple thing, we add event listener, event. It's going to be again Starling events. Just make sure that you are using the correct package, because it doesn't work with the native packages. You have to use the Starling events package. So, and we add event added to stage, add function in it, and we just add a function here, and we have the Starling initialized. So we pass event, and here we can already render on GPU. So let's do one super simple thing here. We'll just draw a rectangle that is called quad, and you say new quad, and it's going to be 100 by 100. It's going to be red, ff00, and so on. And we're going to create an instance variable for that. It's very simple. Add child, queue, and launch the app. Now, it's almost running. This is what you get. It says, this application is not correctly embedded. This means all the stage 3 applications have to be in the direct W mode. So you can either go into HTML template here. Whoops. Open with text editor and set the params W mode equals direct, and now it will render. It's one of the possibilities you can do. Or you can go into the Starling properties and hit this generate HTML wrapper file, uncheck it, and now it will run into the in the Flash player like that. So now we have it running inside the Flash player, which is better. Okay. So it was magic, drawing a quad. Let's do something else here. So for instance, like we want this quad to be positioned on, for instance, like 100, and y is going to be y100 or 100. And then we will start rotating the quad around. So for that, we add event listener, event enter frame. It's going to be loop. We create method loop from here, and we also add the event parameters here. And we say q rotation equals plus equals mat p divided by 180. That's 1 degree per frame. When we run it, oh, it's rotating. Nice. But it's rotating around the left top corner. How to solve that? Well, in this playlist, it was pretty hard because you had to like include this in another sprite, reposition it back, and then rotate it. And that's it's not good. Here in Starling, it's way easier. Just have two properties. One is pivot y, and another one is pivot x. So we just say pivot y and pivot x is going to be 50. This is a half of the size of the quad. And when we run it, it's rotating around the center, you know. So it's a nice little feature that saves a lot of time and a lot of microANAs. So that's good. Is the power coming out of my iPad? Oh. So, what else we want to do? There are some nice properties here in the quad. One of them is set vertex color, and I just have to put it here. It's giving me shocks, electroshocks. So we can set the vertex colors of the quad, and for instance, like we can set the color of this side to, for instance, like green, and set a vertex color of vertex ID into blue. I actually wonder if that's gonna work. And now we have this nice, beautiful quad. So, what if we want to render image? Of course, that's one of the essential things in game development. So for that, let's, for instance, take this stunk image and put it there. So just copy and paste it into my package here. And one of the things we actually do here is we gonna embed this image into the application, and we're gonna call it body PNG, and it's gonna be class, and we just say embed source body.png like that, and it's very simple to add image like that onto the screen. So for that, there is a nice class called image, and it has a helper function which is static, and it says from bitmap, and we just pass the bitmap. So body PNG like that. Just create instance variable of the image here, and just add child image to the screen. Boom, it's there. Simple as that. So now we know how to work with images. We know how to work with quads. That's a good beginning. Be aware here about one thing. This is a nice function, but if you want to replicate the image through the screen and use it like 100 times, then this is not a good use case. Why? Because every single time I call this function, it creates a new texture, new instance of a texture, and uploads it to GPU. So this will actually result in having 100 different textures that are actually same on the GPU. So there's a problem. If we want to reuse the same texture, for instance, like for things like particle effects, or if you are constructing something out of the same textures, like world or whatever, then what you want to do is have one single texture. And for that, we can just say texture, for instance, like texture body equals texture, and again, Starling textures package from bitmap, and we just pass the new body PNG and create instance variable for that. And here we just say new image and pass the texture body. So right now I can create 100 images or 1,000 images, but they will be still using one single texture on the GPU, and it's super fast right now. So right now I can render thousands of these textures. So for instance, if I show you this quick demo, this wouldn't obviously work if all of them were different images on the GPU. But it works nicely if you have one texture and replicate it on GPU. I mean, like 16,050 frames per second, that's really good for rendering. So as you can see, it's very powerful compared to what you were able to do with this playlist. Things like that were just a dream. This is, but rendering, this is even more fast. But be aware, this is fast because the shader that renders that is very simple. So for instance, you cannot do rotation, you cannot do alpha and all these kind of things. So that's why it's so fast. And you can have like 60,000 images running on GPU super fast. You know, it's so fast that it actually makes me sick. Yeah, so what else we have here? So of course, one of the very powerful features of this playlist is movie clips, or movie clips. So let's add a movie clip here. I have this movie clip here defined as a texture atlas, you know, as a sprite sheet. So before, if you are doing animations in this playlist, you are mostly using timelines. You can keep this because the new Flash Pro CS6 actually can export timeline animations into sprite sheets, which you can later on take and reuse inside your animations in Starling, you know. Or there are other tools like Zoe. This is the tool from Grant Skinner. This is animation designed originally in a Flash Pro, and it's a Swift file that I just took and copy, basically drag and drop here into the Zoe, and you just hit the export button, and it will export you PNG and JSON file, and then you can just use these files inside your application. So it will generate from Swift animation a sprite sheet that you can later on use for your own game. Excuse me. Okay, so what do we have here? What actually is exported out of Flash Pro or Zoe is something like that. So first, you have this bitmap, which is one texture atlas, and as you can see, there are a lot of these frames. And how would you actually know the positions of these frames so you can animate them? So for that, there is a helper file, sort of descriptor, that says that frame 0000 is on X, Y, width, height, frame X, frame Y position, and so on. You know. So for each frame, there is a description inside your texture atlas that is generated by some of these tools like Zoe or Flash Pro. And how to render this. So basically, you take these two things, you combine them together, and you create a movie clip, and then you just render the movie clip. So we go back to our game class here, and we're gonna add movie clip. For that, I'll just write MC equals new movie clip. And it basically wants textures and FPS. So for that, we go back here and I basically copy and paste this explosion here. And we include the animation there. So embed, source, explode, PNG. That's going to be the texture. Explode PNG class. And the other file we have to include is the descriptor. So we say embed source, explode XML, private variable explode XML class, like that. But we have to define the MIME type here. So MIME type is going to be application object stream. So now we have these two files, and we're just going to render them. So we go back here into our movie clip, and we actually have to create one more thing here. It's called Texture Atlas. Texture Atlas is a combination of this XML file and PNG texture, or JPEG texture, or whatever texture from bitmap data. So we say Texture Atlas equals new Texture Atlas. And there are two variables you have to pass, as I mentioned before, texture and Atlas XML. So we say texture from bitmap, new explode PNG, and the second file is XML. So we just say XML, new Explo XML, like that. And we close it, close the brackets, and we have texture atlas. Just create instance variable out of it. And here we just pass texture atlas. And here we call function called getTextures. And we can define the prefix here. So what is the prefix? If you look into the XML, you can see every single subtexture actually has this sort of code here, So we can basically target up to 1,000 frames. And the prefix can be EX in this case, or in this case it can be even EX00, So we can basically have, for instance, a huge texture atlas that combines 5 different animations, It doesn't have to be only one animation in one bitmap, Because here we can, for instance, extract explosion animation, and there can be explosion animation 2, which we extract from the same bitmap. And it's a good, and I would say best practice, to keep as, I would say, not so many sprite sheets, If you really want to have everything fast, just make sure that you have everything in just as little as possible amount of textures, So for instance, like Angry Birds texture, well, for Angry Birds, they use just one big texture where they have all the assets together, And using this sort of XML file or JSON file, they define which different sprites and animations are on the texture, So you can combine many animations inside one sprite sheet or assets in sprite sheets. And so what we do here is get textures EX. It will return all the textures. We can define the FPS of each animation and just create instance of that. So now we're gonna add child MC to the main container, and we can run it. But okay, it doesn't display. Reason for that is because we haven't started the movie clip yet, so we just say MC play, and the other thing you have to do is also add the movie clip to the juggler. Juggler is something that takes care of animating things inside Starling, and you just say Starling juggler add MC, and during the life cycle of your game, you can actually add and remove these animations from the process of computation inside the game core. So now we can see our animation is here in the corner. This is explosion, and it's 12 frames per second. We can also run it like 60 frames per second. It's going to be way faster. See, it's very smooth, very fast. So you can actually define for each animation a different speed of rendering, of processing of the animation. That's a very powerful thing, because it allows you to optimize things a lot, So for instance, like in Flash Player, if you had animations, you always had the same frame rate per each movie clip, So that means you had to make the frame animations sometimes really big because you just wanted like slow animation. Here you just define a different frame rate, we'll just animate in a different frame rate, and you don't have to take care of it, which is a very good thing. So what else we would like to add into Starling game? So for instance, particle effects. Particle effects are very powerful, and they allow you to basically add totally different kind of effects that you were used to before. So for particle effects, you can either do them by yourself, which is pretty hard, like program your own particle effects, because what you have to do for particle effect to run it really fast is run it on GPU, even the computation of positions and everything. But there are some editors that make everything very easy for you. So you as a developer, you don't have to take care of designing particle effects. You just tell to your designer, hey, I need these particle effects for this explosion of my rocket, for this fire over there, and so on. It takes one of those particle editors and design the particles for you, and he will basically give you just the XML file and the particle texture to you that you just used for the effect, and that's it, you know. And it's very powerful. So this is one of the particle editors for Starling. This is actually rendering using Starling, so you can really see how this renders inside the framework you are using. There is also one more particle designer that is pretty powerful. This is written in KRCHA. It's for designing particle effects for iOS games mainly, but it exports again into some sort of XML or JSON that you can use in your applications. So it's a standardized way of using particles or producing particles for different kinds of platforms. You know. So this is called Particle Designer. You can pick one of those particle effects here and just use it. For instance, like this one. And if you want to see how to reuse such things, there are a lot of sliders that you can use. For instance, like I can reuse the number of particles, I can make the lifespan bigger or shorter, you know, and so on, you know. So start size can be like this big, you know, and goes there, you know. So a lot of things that you can actually set here. And this is sort of like definition of the standard particle effect, which you then just export into XML. And what actually happens is that it takes the XML file and the texture and uploads it to the GPU onto the shader, which is a GPU program that will process everything on the GPU. And that's why particle effects are composed out of like thousands of objects or hundreds of thousands of objects, and it still runs very smooth. If you were about to do like particle effects on CPU, that would mean like creating a single image instance for each particle. That wouldn't work, you know, because you would be able to render like hundreds of objects, maybe thousands, but it wouldn't be that smooth. Here, it works the way that everything is on GPU, even the computation of the positions of everything, the physics of the particle effect, and so on. Everything is computed on GPU. That's why it's so fast, you know, and you can have like different particle effects on your scene. And this one renders like 2,000 objects. This one renders like 10,000 objects, and so on. You know, so it's very powerful to do things on GPU, to compute them on GPU. So let's get back here. I have this particle effect. As you can see, if I move the mouse, it's following the mouse, and so on. We can actually set a couple different things here. Like this is the X variance. That's the position on the x-axis where it actually starts. You can also define the Y variance, or we can put it back. And we can also define the different gravity, you know, and you can get this sort of nice visual effect. You can really play hours and days with this particle editor to really understand how everything works here. So, for instance, like radius variance for radical emitter. This is the gravity emitter type, acceleration, and so on. You can also edit the texture. Right now we are using sort of like the radial gradient texture, but you can, for instance, like design your own particle. So I just opened the Photoshop here quickly. And we will design our own particle here. Okay, so that was maybe too big. Okay. So for instance, like 20 by 20, and just resize it so it's smaller. We add one more layer here, delete this one, and I don't know, so maybe something simple. Okay. And we just fill it with paint bucket. Save it for the web. Maybe PNG 8, for instance, in this case. Put it on the desktop. It's like our particle. And we just say edit texture, upload the texture, and we pick the particle PNG from desktop, done, and now we have our own particle, which is, it's a little bit stupid particle, but you can see that you can really take any sort of image and just upload it on GPU, and it will replicate the image in the sort of the way that is defined by all these sliders here. So, what else we can, for instance, define here, like the different color, the finish color, and so on. Yeah. So we are basically done with our particles here. Maybe I can make them a little bit smaller, and also the finish size is going to be smaller. And we export the particle into a zip file onto desktop. And here you can see we have our particle.zip. And there are two files. One of them is PEX, another one is PNG. PEX file is basically an XML file defining the configuration of the particle. So here you can see all the definitions we have defined on the sliders, and now we're just going to include this into our application. So if you want to use particles with Starling, there is a special extension for that called particle extension for Starling, and where you get it on GitHub. So we get into the primary Feather repository, which is the repository of Daniel. This is the guy who is behind the Starling framework, and as you can see, there is a Starling extension particle system. And what you basically do here is just download the zip, you unpack it, the zip file, and you can use the particles inside your Starling project. So we just add the source path to the Starling particle extension. I have it already here in my assets. Just pick the source folder and hit open. And what else we do here is we go into our particle and we copy these two items into our Flash Builder folder, for instance here, and then we just include it in our juggler and in our composition. So we save it. We again embed two different things here. One of them is going to be the particle, and the other one is going to be the texture itself. So one of them is particle, the PEX. It's going to be the MIME type application octet stream, and we just close it here like that. Private variable particle definition or config class like that, and then we just embed the texture itself. So texture PNG private variable particle PNG again class, and as before with movie clips, totally same thing. We just say particles equals new particle designer PS, and first thing here we pass is config XML. So we just say new particle config, and the second thing is texture, and we just say texture from bitmap, and we just pass particle PNG file here and close the brackets correctly. Yeah, and create instance variable out of particles, and that's almost it. So what else we do here is we of course add particles to the scene, and then again we have to include the particles in the juggler. So we just say Starling juggler add particles, and then we just say particles start, and now we should have particles on position. We just set the position of the particles to some position so we can see them. Emitter X and emitter Y are the properties you want to use for that. So for instance, like 400 particles, emitter Y is going to be again 400, and we just click the play button here, and we can see our particles are being rendered here inside our Flash animation or Flash application. And we just can take this application, compile it for iOS, display it on our or on our iPad, and it's going to work. So, any questions so far?
So you said that to use Starling, we have to set the mode to direct, right?
Yes.
So what about portal that doesn't support remote direct? Is there an alternative for that? I mean, by still using Starling, but without using direct mode.
Yeah. So right now you have to use direct mode. The reason for that is because some older browsers cannot do composition of GPU rendered thing that are below not GPU rendered thing. You know, like HTML that is not GPU rendered. But the new browsers, like the latest browsers, some of them can actually do this. You know, so there you actually don't have to do direct mode, but that's only for a little amount of new browsers. You know, and the reason for that is the older browser doesn't support that, so you really have to use the direct mode to access the GPU, because it must be the latest layer in the rendering process inside the browser. But for instance, like Angry Birds, they worked with Facebook on adding support for direct mode. So what I propose you to do is to call these guys that are in some sort of portal, or write them email, hey, you should really add support for direct mode, so we can add our applications or games to the portal, you know. But most of the, I think Congregate supports direct mode, and the other guys, like the portals, support direct mode as well. Which portal are you talking about?
Mostly viral portal, smaller portal to viral our games.
Yeah. So Mochi Games, Mochi supports direct mode as well. And yeah. Work with them. That's the only possibility. Any other questions so far?
What is faster, using, for example, creating blood splatter using particle, or just movie clips with Sprite sheets?
It depends on the size of the blood. It's and also of the, you know, if it's like a small little blood, then you can of course use like a movie clip, you know. But if you had like this big blood splatter on the screen, and it should be animated, then you will get like this big bitmap, you know, and it wouldn't even work, you know, because on iOS, the maximum size of a bitmap that is rendered on GPU is 2000 something by 2000 something, you know.
Yeah.
So it's not really a big size of a bitmap that you can render on GPU, you know. So just be aware of that. If you're animating big things, then it might be a big problem in terms of sprite sheet.
So if it's smaller, it's better using movie clips and Sprite.
It doesn't really matter. I mean, like, for instance, for that explosion, which is here in the corner, you could do it with particles, you know, but it's going to look slightly different, you know. Like, as you know, the particle effects are not really looking like the sprite sheets, because with sprite sheets, you can really do everything in Photoshop and pimp up each pixel, you know, and you really have the control over the animation. But with particles, of course, you have control over the animation, but it's, I would say, sort of randomish, you know. It's a different approach, you know.
Yeah, yeah.
So I would say try both and see which one works better for you.
Okay, thank you.
Okay, I have some notes here about things. Yeah, so one of the other things that is definitely worth mentioning in terms of Starling is font rendering. And for that, There are two different approaches. One of them is using a glyph designer, which is this application where you basically choose a font, you choose the texture atlas size, and again it will generate you the sort of like PNG and XML file. Then you can load it, and it will use everything. It will basically combine these two things together, and you can render fonts on the GPU. Because the standard fonts are not renderable on GPU. So what you have to do with the fonts, you have to first convert them into bitmaps, and then you can render them on GPU. So for instance, so this is one of the things that you can use for rendering fonts inside the Starling. This is a standard method for rendering fonts, for instance, with OpenGL on iOS, if you are using Cocos 2D and so on. So it's nothing really new. It's something that is used just normal for developing games. And then there is another option. If you have TrueType font, then you can basically embed it inside Starling, and you basically say which glyphs you want to include, and it will include these glyphs inside your application, and you can use them in your game. It will basically re-render the TrueType font into a bitmap under the hood, and then you can use it. Let me give you a quick example of this font usage. I have here. So first, I have already exported this font here. It's called KRCHA. And I use it for buttons inside a game, and this is basically the XML that is defining the font. So each character has its own ASCII ID that allows you to access the character bitmap inside a sprite sheet and basically render on screen. Just give me a second, I need to find the code for that. Yeah. So, we go back here, and we're gonna basically embed these two things again. So let me just take this KRCHA FNT and KRCHA PNG files and put them here into our project. So what we do here is embed source, which is going to be like KRCHA PNG. This is going to be the font bitmap, and the other thing is going to be KRCHA FNT. It's going to be again MIME type, application of the stream, and this is going to be the font config. And what you basically do here is you say text field no, this text field, but again text field from Starling, register bitmap font, and here it takes parameter of bitmap font. So we just say new bitmap font, and one of the first we import the bitmap font, and one of the first variables is again texture, and the other one is XML descriptor. So it's texture and XML descriptor. We already have these two files, so we just say texture from bitmap. What was it called? Font bitmap. New font bitmap. And the other one is going to be the font config. And we just cast it to XML like that. Yep, that should be it. And now we have basically registered. Okay, so I think there are missing some brackets. Yeah. It's a long line here, so let me split it into a couple more lines. Bitmap font, texture from bitmap, new XML, and now we just close everything. So one more. This will go here. So many brackets. It's really a mess. We should simplify this. What's that? One more here? Yeah, correct. Yeah. Okay, thank you. So now we have registered the bitmap font, and we also we create a button here. You know, that's the last thing I want to show you here today. So we take a button texture, which is this background, and I copy and paste it here. Basically go down here, and yeah, we have to embed the button texture again. So embed source button texture PNG. All these things are actually in the PDF book by Thibaut Imbert that is freely available for you from O'Reilly. So everything is explained there, how to basically work with these things. So say button texture class and private var button, which is going to be just the texture. And what we do here is say we add a play button, which is going to be just class button, and we say new button. We add the button here, which is the texture, and we say play game, and just close it here, say play button, font name, and the font name is going to be KRCHA Axis. It's something which is defined here in the info phase of the KRCHA.fnt file, so it's also imported throughout the process. And just say play button, font size equals 16, play button, font color equals white, play button X equals, for instance, like 110, play button Y equals 510, and yeah, just add child, play button, and should be it. Texture can be null. Nice. So there's some error, but basically this is how you add the button with some custom font that you either created with the Glyph Designer or that you just imported from the TrueType font. And this is basically how it works. I think there is some slight problem here in the texturing the bitmap font, but other than that, yeah, I think what is the problem is this button texture from bitmap, new, what is it? Button texture. That's basically all displayed. Yeah, here we have our button. Cool, isn't it? We made it. So that's good. We are 3 minutes over the time. So you've got my email if you want to contact me. I'll be very happy about that. If you are building something with Starling, definitely let us know. And I hope this was a nice interaction for you to get into the Starling. If you already knew everything about it, I'm so sorry for that. If you didn't knew that and learned something, I'm very glad for you. And I just want to say thank you very much for coming today.